Assalamualaikum and good evening. I am Muhammad Mukrisha, matrix number 2310911161. Our group would like to present Analog Electronics Lab 1, which is BJT Common Emitter Amplifier. Okay, first let's talk about what is DC circuit. Okay, the function for DC circuit. DC circuit is an electrical system with a constant voltage source, allowing current to flow in only one direction. Key components include a voltage source, a resistor, capacitor, and an inductor. Basic DC circuit laws include Ohm's law, Kirchhoff's voltage law, KVL, and Kirchhoff's current law, KCL. Resistors add up directly in series and inversely in parallel circuits. Now let's talk about AC circuit. An alternating current, or known as AC circuit, alternates in direction periodically, typically in sinusoidal waveform. The fundamental principles of AC circuits revolve around the relationship between voltage, current, and impedance. AC circuits are built with resistors, capacitors, and inductors, each affecting the circuit differently. The phase angle between voltage and current is determined by its impedance. Power in AC circuits includes real, reactive, and apparent power. Types of AC circuits include series and parallel circuits. For part 1, DC operation. Okay, for this one, since it is an DC circuit, the circuit is an open circuit. So, the voltage load over here is equal to 0. It doesn't count the V load. So, for the first experiment, without CE or without capacitor, we can see here that we need to find the value for VB, which is this one, 4.75 volt, and this is the waveform, the straight line. Now the VC is 9.62. The VB is here, and the VC is over here. And then for VE is this line here. VE is equal to, VE is here on top of R1, which is 4.0 volt. And V load is 0 since it is an open circuit. For the second one, capacitor is on top of the resistor 1 and resistor 2. So the VC is 9.62 volt, which is this line over here. The VB, this line over here is 4.75, which is right here. VE, this line, the waveform is this one. VE is this line, which is the capacitor connecting to resistor circuit. And V load is still 0. And lastly, for the capacitor in the middle of R1 and R2, the VB is 4.75. The waveform is here. VB is over here. And VC is this line here. 9.62 volt, which is the waveform is this one. And VE, 3.8 volt. VE is this line, the capacitor, and 3.8 volt. And this is the waveform. Okay, now my friend Franco would like to present about.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakhrul Razami and which my matric number is 2310911144. Okay, I will discuss about part B for AC operation, which the circuit is CE remove. For AC operation, we will click here to adjust the in to VC. Adjust the VP to peak is about 0.1 volt. For frequency is 1 kilohertz. That's all. Okay, we're running. Then we will click and here is Vin 99.8 millivolt. Then we will click add here for VLoad over unload. Yes, here. The graph will show up here. Is 69.35 millivolt. Okay, for B is CE in circuit. So this capacitor is connected. Not like the first one is not connected. Okay, V in and same like the circuit one, 0.1 volt, frequency 1 kilohertz. Okay, this is for V in 100 millivolt. Yes. The second one is for VLoad. For VSyn, VLoad is 2.85 volt. Okay, the for the third circuit is the capacitor CE is connected between RE1 and RE2. Yes. So the graph will show up. The V in is 99.8 millivolt, and for VLoad is 1.17 volt. Okay, I will pass to my friend is Muhammad Zamrizal.
Thank you, Muhammad Fakrullah. My name is Muhammad Zamrizal bin Muhammad Zawawi. My matric number 231091169. Now I will talk about the discussion for part A, which is DC operation. This lab investigate the DC operation of common emitter amplifier configuration either for amplifying small voltage signal due to its significant gain. The study analyzed theoretical and practical aspect, particularly at the quiescent or Q point, which provide insight into the amplifier biasing without an input signal, supporting optimal AC performance by reducing distortion and enhancing linearity. Comparing theoretical and experimental Q point using LT Spice establish a baseline for ideal circuit functionality. The role of coupling and bypass capacitor was crucial for stabilizing the operating point. Load variation affected stability and performance with high load resistance maintaining the Q point. Now, next, I will discuss about part B, which is AC operation. This lab examines the AC operation of common emitter amplifier, which has a self-biasing scheme and linear output, making it suitable for amplifying small input signals into largest voltage outputs. Its high voltage gain and current gain make it versatile for signal amplification application. The amplifier high input resistance allows it to drive medium to high resistance load effectively, but it is typically cascaded with a buffer stage to support low resistance loads. Overall, the AC analysis emphasized its effective in application requiring significant voltage and current gain. For the conclusion for this experiment is the experiment examined the DC and AC operation of a common emitter amplifier, confirming its accuracy and stability. The DC analysis used a LT spice to compare theoretical and experimental value of the question operation point, revealing the impact of coupling and bypass capacitor on the coin. Different load conditions were also evaluated, highlighting the importance of load consideration in amplifier design. The transistor operational DC load line was analyzed, confirming theoretical expectation. The AC operation analyzed confirmed the amplifier expected gain, highlighting the importance by bypassing emitter resistor for maximizing gain. The experiment validates the theoretical design and ancient understanding of common emitter amplifier behavior under both conditions. That's all